Part 2, Stacks and Queues. Now, if we're talking about stacks, we're talking about arrays. Here is our linear list array. And we know that a pointer is required to point to the last item added to the stack. We're going to call this a top of the stack pointer. So what value are we going to give that in this example? It's going to be the value of 4. That is our top of the stack pointer. Let's have a look. Yep, there it is, and we store that value. We know that in a program module we're going to store that value as a variable. We've got to know which item was added last, because this linear list, this array, is typical of the stack method, last in, first out. So how do we add to this? Well, very simply, we need to change our top of the stack pointer. Let's have a look. Before we look at how we do this, though, let's have a look at the pseudocode for each item in the list. If that item has the desired value, then stop your search and return the item's location, i.e. the index. Let's have a look. So if we were searching for something, we would return 1 if it was Greg. This is the pseudocode that describes the result of a search in an array. It's going to return the location of that list item, or the invalid location indicated by that upside down V. This indicates that the desired element does not occur in the list. Remember, it's going to be an error, and this is all part of error handling from AS. It's going to be an error if it's not there, because, well, if there's no value, we can't really do anything. We have to say null return. Of course, we can make an escape clause for that. We can do this recursively. Look at this recursive algorithm. Here we go, the linear search. And what's involved in our search? Well, we've got the value, which helps with our pointer, and we've got the list item, the names. So if the list is empty, once again, return null, if you like, or no value, or in this case, that actually means return an error. So we need to handle that error. This is great for an algorithm because we're not worried about the program. We just simply say return an error, and then when we program it, we would have to deal with how we handle that error. Else, if the first item of the list has the desired value, return its location. Else, return linear search value remainder of the list. So keep going through the list. This is interesting because this will cast your minds back to AS, sequential searches and bubble sort, and all that kind of thing. So this is moving down the list, and we found it, return the location, otherwise continue looking for the value in the remainder of the list. A very simple recursive algorithm, and one to remember. So let's add an item to the stack. Let's have a look at how this works. At the moment, our top of the stack pointer is pointing number 4, Fred. But we want to add something. We want to add Ben. So we're going to change from 4 to 5. What are we changing? The top of the pointer stack. The top of the stack pointer, sorry. The top of the stack pointer is now 5. And we just move our arrow to show that. Okay. Linked list method. For this, I can't do any better than page 96 onwards in your textbook. And this is what we were dealing with recently. When I say recently, towards the middle and end of February, when we were looking at arrays and linked lists. And like I said, 96, 97 in your textbook, ideal for this, and definitely one to look at for the exam. You will get a question in the exam on linked lists, and relate this to how we use stacks. Next up, queues.